Hi guys, welcome back to this concept-based YouTube channel to all my dear viewers. Today, I'll be explaining Theorem 2 and Theorem 3, Chapter 6, Lines and Angles. The first theorem that we have today, it is, if a transversal intersect two parallel lines, then each pair of alternate interior angle is equal. This is the first theorem that we have today. In order to understand this theorem, first, we need to draw some figure. Okay, here we have AB and CD. These are the two lines and parallel to each other, and in addition to this, we draw another line which intersect these two parallel lines and make some angles. All right, and whenever it talks about alternate angles, then you just imagine that it is the angle which is in that side as well as in that side. So this kind of angles we'll call it as alternate angle. But here, what is that? It is interior. Interior means the one which is inside this line as well as this, means whatever angles that we have in this. So we can summarize it from the theorems. It is all about whenever there is two parallel lines and one line intersect its two parallel line, then whatever angles that we have inside it, all these interior angles should be equal. One should be equal with angle 2 and angle 4 should be equal with angle 3. Okay, this happens only when two parallel lines are intersect by another lines. Okay, angle 1 will be equal to angle 2, and after that we have angle 4, and angle 4 will be equal to angle 3. All right, these situations happen only when there is two parallel lines and these two parallel lines are intersected by another lines. Then in that case, alternate interior angles are equal. This is all about theorem 2. And now let us move to theorem number 3. In theorem number 3, we have the theorem which is almost similar with theorem 2, but the difference here it is just converts to theorem 2. Okay, so this is the difference only we have in this. First, we can see that if a transversal intersect two lines such that a pair of alternate interior angle is equal, then the two lines are parallel. Here, first we are given with two parallel lines and intersecting the two parallel lines, which we call it as a transversal. So if it is these things are there, then the alternate interior angle should be equal. So this is theorem 2, and unlike in theorem 2, here the one which we need to see it that was given in this, and now we need to prove it whether these two lines are parallel or not. Okay, so if these two are parallel and there is a transversal which intersect these two lines, then this angle which is alternate interior angle should be equal. There is no doubt in that. All right, now in theorem 3 we are given with this part and we have to prove this one. Okay, whenever this is there, then this is there, and whenever this is there, then this is there, right? And here we are given with this part, and this part is given to us, means we have this kind of lines, means parallel lines as well as transversal. Okay, so that's the proof. I hope everyone can understand this. Here we have angle 1 equal to angle 4, and after that we have angle 4 equal to angle 3. Now if we have these two, then we can draw a line. So let me draw this one as AB, and after that let me draw again another line which is parallel to AB. I'll call it as this one CD, and after that I'll be drawing another line which will intersect these two parallel lines, and I'll be naming this as a transversal PQ. Okay, and whatever angles that it is there, So here all these angles are equal, and thus the two lines which we do not know earlier, these two lines are parallel as these angles are equal. Okay, and after that these two lines are equal and this lines is called transversal. So that's it, theorem number 3. I hope everyone can understand this. So let us stop up to this, and if we have a time then we will see in the next videos. Thank you. That's all for today. Wish you all the best.